Hello students. So today we are going to see two fundamental results in calculus. Okay, mean value theorem and Rolle's theorem. So Rolle's theorem says that let f, the function is defined from a closed interval ab to r. Okay, it is continuous on ab, okay, closed interval ab, and differentiable on open interval ab. Okay, such that f of a is equal to f of b, okay, where a and b are some real numbers. Then there exists some c in this interval such that f dash of c is 0. This is what Rolle's theorem says. Okay. So for example, if you take a function y is equal to x square plus 2, okay, and a and b are given, that is your interval is given -2 and +2. Okay, so this is continuous. You have to check for left hand side continuity, that is left hand limit, right hand limit. Okay, this will be same, right? Because here x square is given, so -2 square and 2 square, it will be same. So it is continuous on closed interval -2 to +2. And differentiability also you have to see, that is right hand derivative and left hand derivative. So it is also differentiable. Then we have to check for f of a and f of b. So f of -2 is 4 plus 2, 6. And f of 2 is also 6. So both are equal. So there exists a c belonging to -2, 2 open interval such that f dash of c is 0. So if I take y dash, that is derivative of this, it is 2x. Okay, when it will be 0? When x is equal to 0. Okay, so our c value is 0. So f dash of c is 0. Okay, so Rolle's theorem is true for this function. Okay. Next is mean value theorem. So let f function is defined from closed interval ab to r. This is continuous on closed interval ab and differentiable on open interval ab. Okay. Then there exists a c belonging to open interval ab such that f dash of c is equal to f of b minus f of a upon b minus a. Okay, this is what our mean value theorem says. So this is nothing but the slope, right? That is the derivative. So if you take a function, say for example f of x equal to x square, and the interval is given 2, 4. Okay, so this is continuous in 2, 4 and differentiable in 2, 4 because its derivative is f dash of x is 2x. Okay, now we have to see f dash of c, f of b. So f of 2 minus f of 4 minus f of 2 upon 4 minus 2. F of 2 is 16, f of f of 4 is 16, f of 2 is 4, 4 minus 2, 2. So this is 12 upon 2, which is 6. Okay. So f dash of c is 6. So from this we can say that 2x is equal to 6. So x is equal to 3. So we have a point C which is 3 belonging to the interval 2, 4. Okay, this is mean value theorem. That's all exercise 5.8. Okay, so exercise 5.8 first question. We have to verify Rolle's theorem for this function. Okay, so Rolle's theorem, it is a polynomial, right? Quadratic equation. So this is a polynomial. Polynomial function is always continuous and it is also differentiable. So f of minus 4 and f of 2 we have to find. F of minus 4 is 16 to minus 8 minus 8. So this is 0. 4 plus 4 minus 8. This is also 0. So this implies f of a is equal to f of b. Right? Then we have to find c such that f dash of c is 0. So f dash of x is 2x plus 2. So if I take it equal to 0, this will be x is equal to minus 1. So c is our minus 1 which belongs to the interval minus 4 comma 2. Okay. So the Rolle's theorem is verified. Next question is you have to verify Rolle's theorem and three functions are given. Okay. So this is greatest integer function. So the interval is defined like this 5 comma 9. Now we know that this function is not continuous at every integral point, that is at x is equal to 5 and x equal to 9 the answers will be different, right? It is not continuous. Then first condition not continuous. Okay, on 5 comma 9 closed interval. Then we have to check for differentiability. Okay, that is we have to go for left hand derivative and right hand derivative. Okay, on the interval, say some c belonging to 5 comma 9 open interval. Okay, so left hand derivative limit as h tends to minus c plus h minus f of c upon h. This type of problems we have done earlier also. Okay, for the greatest integer value. So this will be c plus h c upon h. So for this value, it will be c minus 1. Okay. Because this is 0 minus. So we are approaching from the left hand side of 0. And this is c. So this will be minus 1 upon h, which is infinity. Okay. For right hand derivative, it will be limit as h tends to 0 plus. Okay, same way you have to do. Only thing is here it will be c. Okay, we are approaching from the right hand side. So this is 0. Okay. Since left hand derivative and right hand derivative are not equal, we can say that it is not differentiable at x equal to c, which belongs to the interval 5, 9. Okay. So it is not differentiable. Then third thing we have to see is that f of 5 and f of 9. So that is also not equal, as f of 5 will be 5 and f of 9 will be 9. Okay. So this function does not obey Rolle's theorem, or the Rolle's theorem is not obeyed by this function. For second one, also it is given greatest integer function. So same steps you have to follow. So here also Rolle's theorem is not applicable. Okay. Let's see the third equation. F of x equal to x square minus 1. X belongs to 1, 2. Now this is a polynomial function. Okay, so it is continuous. Okay, and also it is differentiable on 1, 2. Okay, now let's see f of 1. This is 1 minus 1, 0. F of 2, which is 4 minus 1, 3. So f of 1 is not equal to f of 2. So Rolle's theorem is not applicable. Next question. So here the function is defined from minus 5 to r. Okay, minus 5, 5 to r. We have to prove that f of minus 5 is not equal to f of 5. It is given differentiable function. Now we know that differentiable function implies that it is continuous. Okay. And second thing which is given is f dash of x does not vanish anywhere. So if you want to apply Rolle's theorem, then it will be difficult because f function is not defined here. Okay, any specific value is not given. We can use mean value theorem. Okay. So first we can say that f is differentiable implies f is continuous. Okay. So applying mean value theorem, so there exists a c belonging to minus 5, 5, okay, such that f dash of c is equal to, okay, by mean value theorem. F of minus, no, 5 minus f of minus 5 upon 5 minus of 5, okay. This will be 10, so 10 f dash of c, okay, and it is given that it does not vanish, that is f dash of x is not equal to 0. So our f dash of c is not equal to 0. So this thing is not equal to 0, which implies f of 5 minus f of minus 5 is not equal to 0. So we can say that f of 5 is not equal to f of minus 5. Okay. Next question. Verify mean value theorem. F of x is given minus 3 in the interval a comma b, where a is given 1, b is 4. Okay. Now this is polynomial function. So it is continuous on closed interval 1, 4 and differentiable on open interval 1, 4. Okay. Now mean value theorem means there exists a C belonging to 1, 4 such that f dash of C is equal to f of 4 minus f of 1 upon 4 minus 1. Okay. So this is equal to f of 4 is, we have to put value here. So 16 minus 4 4s are 16 minus 3 1 plus 4 minus 6. So this is minus 9 upon 3. So this is minus 3. Minus of minus 6. Okay. So plus 6. So 3. 1. F dash of C is 1. What is f dash of x? F dash of x is 2x minus 4. Value we are putting equal to 1. So 1 plus 4 is 5. X is 5 by 2. So this is our C. So 5 by 2 belongs to interval 1, 4. This will be 2 to the 4, 2.5. Okay. So mean value theorem is verified. Next question. So f of x is given and interval is also given. You have to find all the C belonging to 1, 3 for which f dash of C is 0. Okay. So again this is a polynomial function, so it is continuous and differentiable. Continuous on this interval, differentiable on this interval. Okay. And using mean value theorem, there exists a C belonging to 1, 3 such that f of 3 minus f of 1 upon 3 minus 1. So this is 3 cube 27 minus 45 minus 3 3 is 9 minus f of 1 minus 5 minus 3. So this will be 27 minus 27 8 minus 1 7 minus 20 upon 2, so minus 10. Okay, this is our f dash of c. Now find out f dash of x. 3x square minus 10x minus 3. Okay. This is equal to minus 10. So 3x square is 10x minus 10 plus 3 is minus 7. So plus 7 equal to 0. So we get this quadratic equation. So find out factors. This will be 21 and minus 10. So 7 3s are. Okay, minus 3 and minus 7. So x is equal to 1 and x is equal to 7 by 3. That is, these are our C values. Okay, both 1 is not in the interval 1, 3. So we have to choose 7 by 3. So this is our C, for which f dash of C is 0. Question 6, you have to examine the applicability of mean value theorem. Now here the same functions are given which we had seen in earlier questions. That is, this is greatest integer function and the interval is also same. So there we had proved that Rolle's theorem is not applicable. The same conditions are there for mean value theorem also. That is, this is not continuous, this is not differentiable, and f of a is not equal to f of b. So here also mean value theorem is not applicable. Okay. For second one also it is not applicable. Let's see the third function, x square minus 1, 1 comma 2. So this is a polynomial function. So we can say that it is continuous and differentiable. Okay. Now we have to check for that f dash of c. F of 2 minus f of 1 upon 2 minus 1. F of 2 is 4 minus 1 upon 2 minus 1. So 3 upon 1, which is 3. F dash of x is 2x, which is equal to 3. So x is equal to 3 by 2. Okay. Now let's see whether this 3 by 2 falls in the interval 1 comma 2 s. Okay, this is 1.5. So this is our C.